Bismillahirrahmanirrahim. Now we will study in this lecture some problems. You can say some more properties of the product of permutation symbols and some problem related with the indicial notations for the vector identities. Now this is the first problem, that we have product of this and it is equal to this. That you can see that we have only one dummy index and m and four free indices I, j, k, l. So by using these four free indices, we can have following 6 cases. Either I is equal to j, I is equal to k, I is equal to l, 3 cases. Then j is equal to k, 4th, j is equal to l, 5th, and then k is equal to l, 6th case, number 6 case. Now let us start with the first case. So in first case we have I is equal to j. Now for I is equal to j, we have to show that left hand side equals to right hand side. Let us take for I is equal to j, so it means that value can be 1, 1, 2, 2 or 3. Suppose it is 1. Suppose it is 1. So on left hand side it would be epsilon 1, 1 m epsilon k l m. So this would be 0. Whatever the value of k, l and m, this would be 0 because we have repetition in the indices of this permutation symbol. Similarly on right hand side, delta 1k delta jl minus delta 1l delta 1k. So these will be cancelled out with each other and we have right hand side 0. So left hand side equals to right hand side. This is with supposition, this is with our supposition when we are taking ij equals to 1. So you can take 2 and 3. Result must hold with these two assumptions also. You have to check this. Now let's go to the second case when I is equal to k. Now for I is equal to k, it means that we will have to take this I is equal to k. So value of these two dummy indices will be same. As in first case, values of free indices I and j will be same. For second case, values of free indices I and k must be same. Suppose we have value 1, that we have 1, it can be 2 or 3. If it is 1, this is first supposition, it can be 2 or 3. So if it is 1, then left hand side would be this epsilon 1 gm epsilon 1 lm, that we have made I and k 1, 1. Now you have summation on m, so let's expand m. So we have 3 terms, this plus 1 plus 2 plus 3. And on right hand side, by using 1 instead of at ik, we have this is 1, delta 1, 1, and these are the second term, delta 1l delta jl, right hand side of your given. Now we have some sub cases in this case when I is equal to k is equal to 1, because we can see that left hand side and right hand side. So we have two dummy indices j and l. We are left with two free indices j and l. I, k free indices, we have used their values 1 equal and 1, and we have expand the dummy index m. So we have only two free indices j and l. So we have sub cases for these two free indices j and l. They can be different with each other and they can be same with each other. So when they are different with each other, j and l, when j and l are different, that it can be, if j is 1, then jl can be 2 or 3. That we have these 6 pairs, different 6 pairs, that j and l. First pair is 1 2, second is 2 1, 1 3, 3 1, 2 3, and 3 2. That here is j is 1, l is 2. Here j2 l is 1, j1 l3, j3 l1, j2 l3, l3 j2. So we have 6 different options which we can take for first sub case when j is not equal to l. Suppose we have j is equal to 1 and l is equal to k. So left hand side, when we use j is equal to 1, this would be 0, this would be 0, and this would also be 0. So left hand side is 0 for this pair. So let's see what happens with the second with the right hand side. So this is 1, and when j is 2, j is 1 and l is 2, delta 1 2 0, minus delta 1, l is 2, delta 1 2, and j is 1, delta 1 1. So this would also be 0 and this is also be 0. So right hand side is also 0. So for first sub case, when j and l are different, you have left hand side equals to right hand side, they both are 0. Then you can write these two are equal. Now the second sub case. In second sub case, j is equal to l, and in third sub case, j is equal to l. But for further, it can't be equal to I, and it can be equal to I. What is I? I and k both free index for which we have used value 1. That second sub case, in second sub case we are supposing that j is equal to I but not equal to I. J is equal to L but not equal to I, and here I is 1, so it means I and k is equal to 1. So it means that j is equal to L but not equal to 1. So j and l can be 2 or 3. So if it is 2 or 2, then this is the left hand side. 1 to 1, 1 to 1, 2 to, this would be 0, this would also be 0, this is plus 1 and plus 1, and left hand side equal to plus 1. No, for right hand side. For right hand side, delta 1 1, delta 2 2 minus delta 1 2, delta 1, this will be 0. So this is 1, this is 1, so right hand side 1. So left hand side equals to right hand side. So this would have, so left hand side is equal to right hand side when we have j is equal to and not equal to I. Now what is left hand side? 1, and what is right hand side? Left hand side is also 1 and right hand side is also 1. Now if j is equal to I but j is equal to L but also equals to I, so here it would be j is equal to L is equal to 1 because I is 1. So left hand side will be 0 and also right hand side will be 0. So again we have left hand side equal to right hand side. So if we will consider all the cases like this, that I is equal to k is equal to 2 and I is equal to k is equal to 3, and do all the process as I have done for this supposition for I is equal to k is equal to 1, we have and all sub cases we have left hand side equals to right hand side in each cases. Then after all this, we have concluded that our left hand side and right hand side are equal, and they are equal to this, that if J is not equal to L, left hand side right hand side is 0. If J is equal to L is equal to I, then it is again 0, as we have seen here. If J is equal to L and not equal to I, then 1. Now you have to do this thing for when I is equal to K is equal to, and you will see that you will again have this type of result, and also for I is equal to K is equal to 3, and you will again have this type of result. So we can generalize the result of part 2, that we have proved that left hand side is equal to right hand side for part 2, but we have also concluded that left hand side is equal to right hand side is equal to 0, and 0 when this and this, and 1 when this. Now you have 4 other parts. You have to do the same thing as I have done for second case for part 2. For 3 you will have to take I is equal to L. You can take 1, then 2, then 3, then similar cases, then you will have this result. Then you will use J is equal to K, then you can use 1 or 1, 2 and 3, then you have this you will have this result. Then for like J is equal to L, again you will have this type of result, and when K is equal to L, then both left hand 0 and right also 0, as in case 1. Case 1 and case 6, they are simple cases. Simply in 1 and 2 steps you have the result 0, 0. No, here I have written the most general relation for the product of permutation symbols and the Kronecker delta. You can see that we have product of permutation symbols on left hand side, and on right hand side we have 6 terms, and in each term we have product of Kronecker delta, and that is appearing 3 times, and left side you have 2 times epsilon, and on right hand side you have 3 times delta in each term. But you can also see that on left hand side all the indices are different, I, J, K and P, Q, R. So all the 6 indices are free indices in this relation. Now what you have to do by using this result, I am not asking you to prove this result. I am asking you use this result and show that this product is equal to this. You can see that on left side you have 1 dummy and 4, and I, J, K, L 4 are free. So now you have to make K is equal to R is equal to M, and similarly you have to do this thing on the right hand side, and you have to obtain the result that at the end you must have this. On left hand side this is the straightforward for left side, but you have to do something more to obtain this right hand side. Now this is exercise for you. Now this is the vector identity. This is A cross B cross C. We have three vertices, vectors A, B, C, and right hand side A dot C into B minus A dot B into C. Now we will have to prove this with the help of indicial notation, and in which we will use the product of permutation symbol. Now A cross B cross C, this is simple the definition here we have used simple definition of B cross C, like here we are using B cross C. This is what at A, instead of A we are using A and EM, A1 E1 plus A2 E2 plus A3 E3. This is the summation convention, AM EM instead of this vector A. Cross B cross, definition of B cross C. Bj Ck epsilon Ijk Ei. Now you can write this AM epsilon Ijk AM Bj AM Ck and EM cross EI. Now you can use EM cross EI like this, that you know that EI cross EJ equals to what. So here J is M and I is M and J is I. So you can write this epsilon MIN. Simple. No rearranging, epsilon IJK epsilon MIN and AM BJ CK EN. No, we are writing this thing like JKI is MNI. Sorry, this is NMI. This is NMI. Here we have JKI NMI. So this is the same as this. This is dummy MM. Here we have dummy II and 4 free, and this is JK and M. So instead of this we are writing this thing. We have this, and these are similar, AM BJ CK EN. Now we will multiply these things and we have this and this. Now you can use the properties of delta, that delta Kn AM it would be AK, delta Jn Bj it would be Bn, Ck as it is, En as it is. You can use this delta Km with Ck, that you will have Cm. This is up to you. Similarly on this term, this second term, delta Jm with this Aj, delta Kn with this Ck it will be Cn, Bg as it is, and En. So this AKCK is A dot C. In previous lecture, A dot B equals to AIBI. So AKCK is A dot C, and B and En is B. That B is equal to B1 E1 plus B2 E2 plus B3 and E3, and it is B is equal to B and En. Similarly here, A dot B and C. So this is the right hand side. So in the next question, it is given that Tij is equals to minus Tji. It is given that Tij equals to minus Tji, and we have to show that this product equals to 0. So Tij Ai Aj will be equal to this. We are interchanging the indices I and J. We can do this, both in changing J and I and J and I, but tji equals to minus tij, so it would be minus tij aj ai, and this can be written as plus 2 on left hand side, 2 times tij aij equals 0 0, and tij ai aj equals to 0. Now you have to show this if tij equals to minus tji and sij equals to plus sji. One is plus and one is minus. You have to do this. And these are some more exercises. These are some more vector identities. You have to do this. You have to do all these as I have done this identity. You have to do all these identities. I have told you that what is divergence of any vector, and so making use of that thing, you have to do this. Thank you so much.